Hi everyone, my name is Amy Williams and I'm currently studying biomechanics at university. Today I will be critiquing the GPS system or global positioning system and how that works with the health applications on our smartphones. So just in general, I'll be using the Samsung Health application today. It's just the one that came with my phone. It's pretty stock standard. It can be downloaded on multiple devices, so it's not exclusive to Samsung. Now I'll be looking at how this technology can be used to enhance the performance of long distance runners. So I'm talking 5 kilometers and more. Being that biomechanics looks at the mechanical laws and the structure of movement, it makes sense that biomechanists have been using and enhancing technology to not only increase sport performance, but also to increase health, fitness, rehabilitation, range of movement, and just a general understanding and a science behind how the body works. It's for this reason that I've chosen the smartphone, because these days everyone's got one. They can be bought at a wide variety of prices. All models these days are installed with a GPS system and have the basic software and ability to download an application if required. This device is not a wearable. It can be handheld, placed in your pocket, or secured on those armbands that people run with. It's user-friendly, straightforward, no fuss. You just select your distance, press go, off you go. But if you want to make more advancements, you can. So you can find yourself in a huge rabbit hole of information, applications, upgrades, additions, things like your GPS, smartwatches, mapping, data analysis. The list is endless. So you can advance the technology if that's what you need to do, if that's what you want to do. For the purposes of this critique, I will be using the stock standard as the app comes, but it can be enhanced if required. Now, this application works best for longer distances, so your 5 kilometers plus. People who are looking to compete in marathons, fun runs, have a personal goal for distance or time with their own running. Now, a long distance runner, their biomechanics different from a short distance runner in many ways. So the pace is slower, the velocity is decreased. This kind of distance requires the runner to find a pace that can be sustained over the distance. So they have a higher rotary stability, and as the runner begins to, let's say, shuffle, so as they become slower towards the end of their run, their base of support and center of mass is adjusted to become more stable for them. Now, the gait during a long distance run means that the runner is in contact with the ground for a lot longer. They're also not pushing from just the ball of their foot like they would if they were a sprinter. They can be using midfoot and even heel as they're running. Now, the momentum, less momentum is required when compared with a sprinter. So your sprinter is far forward, trying to push and force the momentum at a faster rate, using much more force. We still need to shift our center of mass and create that momentum, but so it is a little bit more anterior than in standing position, but we don't need to use as much momentum as a sprinter. Now, muscle force is also manipulated to become more sustainable over a distance. So where your sprinters are pushing off, they're sprinting short distances using a lot of force that's unsustainable. Your long distance running is all about finding a pace that you can sustain for the distance that you've chosen to run. Friction's also increased. Like I said, you've got more base of support, so more base of support in your feet and your gait. Now, the GPS tracking system on our phones works by calculating our linear displacement from one location to another. So what happens is the satellites, they locate our coordinates at a frequency, depending on your device, of 1 to 10 hertz per second. So obviously, the more hertz per second, the higher the frequency that this data is being sent off. Now, this data is called a ping. So essentially, the GPS is tracking your linear displacement from one ping to the next, and so on. So displacement from one ping to another. Velocity is then calculated by the change in displacement divided by the change in time, and that gives us an overall general feedback of our performance. Accuracy is within 3 meters these days, so from your exact location to 3 meters away. So there can be miscalculations for various reasons, which we'll dive into in a second. It's for this reason that it's not effective for sprinters and track runners, because they're darting, they're changing their directions, they're linear, they're not so much using linear displacement at a good ping frequency. A good example of this, and I've just got my whiteboard here, is a 400 meter track. So let's say we've got a runner running around a 400 meter track. So this is the ping frequency, so this is where the data is being sent out, let's say. Now, the ping frequency is going to measure your linear displacement from one ping to another. Now, as you can see, your displacement is accurate, but your distance is inaccurate. So you're missing the bends, right? So that's a good example of why this is better for your linear tracks, your linear running. I've done this on my smartphone. On my first run, I set my settings to only track when my screen was on, and it showed me running through a whole heap of buildings. I showed my displacement, but it didn't show my distance very well, so I didn't end up running as far as I thought I'd run. Now we can see when we are using the app correctly, an overall example of our pace and cadence and how we can adjust ourselves. So for example, when I was training for a 10-kilometer run last year, my first run, I ran at a speed of 5 minutes 40 per kilometer, but then towards the end, I was running at 6 minutes 50 per kilometer. So quite a large difference. So I used this to assess my pace and start with a slower pace, more sustainable over the distance. So on race day, so on my 10-kilometer day, I kept a steady pace over the entire distance, smashed my time goals, but also my fastest kilometer was the 9th kilometer. So you know, when you're starting to see the finish line and you just want to get there. So I had a sustainable pace, and then, you know, that short burst of energy as well helped me to increase my performance goal. In terms of cost, this application is free. So most of your health applications are free. You can opt to purchase some, but for the general basic apps, it just comes with the phone. It's cheaper than a GPS watch. Most people already have a phone. You're not going to buy a phone just for the GPS. If you were going to buy a GPS to be a GPS, you would buy a wearable, I'd say, because they're more accurate. You can buy extras, but that's optional. So let's just say you wouldn't buy it for the GPS. It's just a nice bonus to have, and it's nice and easily accessible on your phone. Advantages is the ease of access. User-friendly, shows data including maps, cadence, speed, pace, has the ability to split this data over kilometers or segments, so you can choose 500 meters, 100 meters. So it splits the data and it shows it in a, I don't know if you can see that very well, it shows a total summary, including, you know, your calorie burn and everything like that. You can share this data with friends, coaches. People use this application to train together, so to increase the sociability of it, I guess. Technology can be enhanced through the use of smartphones, heart rate monitors, things like that. You can also use this device for other sports, so like hiking, swimming, skiing. It even has calorie burn for things like bench press, if that's what you're going for. Tracks performance data and stores it, so you can go back in time and have a look at what you were doing, see if you've improved, see where you need to make improvements. So it's all very easily accessible. Disadvantages, obviously the inaccuracy when the frequency of the ping is not enough. So a cloudy day, or unavailability of a satellite, multi-patching, so signals bouncing off of buildings or mountains nearby. So it's limited to a higher accuracy on linear paths, is essentially because of the accuracy is up to 3 meters. So it's really good for general training, but not really for highly competitive training athletes. It is reliant on battery life, so you obviously got that limitation. It's handheld, so it can be uncomfortable for some, as it's not a wearable. So an overall view, I use this app because it's simple. It gives me a fair idea of whether I'm improving in my running performance and where I can improve in my running performance. It helps with general fitness measures like your heart rate, and it includes a pedometer. If I was an elite competitor, I would most likely buy a more accurate tracking device. But this is a great form of technology for your general public and for your beginners, essentially. Thank you for listening to my review of the GPS phone applications and their use for long distance running. I hope you've taken something from it. You've been listening to Amy Williams. Enjoy the rest of your day.